Hi, my name is Sophia Zane, and today I'll be explaining the 2015 FRQ question number 3. The question reads, Joanna jogs along a straight path for t is greater than or equal to 0 and less than or equal to 40. Joanna's velocity is given by the differentiable function v. Selected values of vt, where t is measured in minutes and vt is measured in meters per minute, are given in the table above. And the first part is asking for us to use the data in the table to estimate the value of v derivative 16. So for the first part, we can use two surrounding values to approximate the value of v derivative 16, which in this case is when t is equal to 12 and when t is equal to 20. So for part A, v derivative 16 is approximately equal to v of 20 minus v of 12 over 20 minus 12. And we substitute in the values, so we get 240 minus 200 over 8. This is equal to 40 over 8, which is then equal to 5 meters per minute squared. And this part is only worth 1 point, and that is just for simply approximating or getting an answer. So part B is asking for us to explain the meaning behind the definite integral given, and also to approximate its value using right random sums. Okay, so this given integral, absolute value v of t dt, represents the total distance she runs in meters over the given time interval, which is t is greater than or equal to 0 and less than or equal to 40. Okay. And then in order to approximate this, we break it up into rectangles using the right-hand values. So then it would be 12 minus 0 times absolute value v of 12 plus 20 minus 12 times absolute value v of 20 plus 24 minus 20 absolute value v of 24 plus 40 minus 24 times absolute value 40. Alright, so then we substitute in values and simplify this a little bit. We get 12 times 200 plus 8 times 240 plus 4 times 220 plus 16 times 150. And then we simplify a little more. 2,400 plus 1,920 plus 880 plus 2,400. And adding this all up, we get 7,600 meters. So in terms of scoring, you get 1 point for getting this explanation correct. And it's best to be as specific as possible, or else you could possibly be wrong and they'll take points off. And you get another point for doing right random sums, and then you get another point for just putting this answer. So in total, part B is worth 3 points. So for part C, we are introduced to Bob, who is riding his bicycle along the same path, and his velocity is modeled by the function b of t, where t is also measured in minutes and b of t is measured in meters per minute. Okay. And they want us to find Bob's acceleration at time t equals 5. So acceleration is just a derivative of velocity, so we have to find the derivative of b of t, which is equal to 3t squared minus 12t, and then we substitute t is equal to 5 in, so we get 3 times 5 squared minus 12 times 5. This is equal to 75 minus 60, which is then 15 meters per minute squared. And For scoring, you get 1 point for finding the derivative of b of t, so 1 point for finding the derivative correctly, and then another point for getting the answer. So part C is worth 2 points total. So the final part is asking for us to use the function given in part C to find Bob's average velocity during the interval t is greater than or equal to 0 but less than or equal to 10. So average velocity is represented by 1 over 10 minus 0 times the integral 0 to 10 of b of t, which is t cubed minus 6t squared plus 300 dt. And we can simplify a little bit and also take the antiderivative of this part over here to evaluate. So we get 1/10 times t to the 4th over 4 minus 2t cubed plus 300 t 10 0. And then since multiplying by 0 is 0 and subtracting by 0 does nothing, we can ignore this part down here. And by plugging in 10, we get 1/10 times 10,000 over 4 minus 2,000 plus 3,000. And we can simplify once more and get 1/10 2,500 plus 1,000, which is then equal to 1/10 3,500, which is then equal to 350 meters per minute. And once again, as for scoring, we get 1 point for setting up this integral correctly. We get another point for taking the antiderivative correctly as well. And then another point for this answer right here. So in total, the last part, or part D, is worth 3 points. So this FRQ was relatively straightforward, but if you struggled with it a little bit or had some issues knowing when to use what, I would suggest going over the topics of application, derivatives, and integrals once again, as this is basically what the FRQ is entirely about. If you're just looking for further practice, I would suggest looking at the Calc AB 2002 FRQ number 3 and 6, as these questions also look at application of derivatives, and they also use a table similar to this question. And if you're just looking toward like interpretation practice, I would recommend looking at 2014 number 1, because it also asks for an interpretation part, just like part B over here. So thanks for watching, guys, and I hope this video helped.